Assalamualaikum and a very good day to everyone. Today, my group and I will be presenting about amplitude modulation or simply SNAM. This is one of the fundamental techniques used in a communication system for transmitting information over long distance. Before we begin, here are the members of our group 10. First is myself, is Ahmad Aiman Syahmi, followed by Syaki Iman, Kabil Johar and Muhammad Hakimi. Together, we will explain the basic application and type of FM. Move on to the what is an amplitude modulation. Amplitude modulation is a technique where we vary the amplitude of a high frequency carrier wave according to the message signal. The message could be audio, voice or data. What's important to note is that the frequency and the phase of the carrier will remain constant, only the amplitude changes. This method allows signals like voices or music to travel long distance using radio waves. How AM works? The basics to understand on how AM works, it can be broken into simple steps. Step 1, we need to generate the carrier wave. A carrier is a stable high frequency signal. It acts like a vehicle that will carry the information. Secondly, we will create the message signal. The message is a much lower frequency signal, usually audio or data. Thirdly, we will do a modulation process. The amplitude of the carrier is adjusted based on the amplitude message. When the message gets stronger, the carrier amplitude increases and vice versa. Next step is a transmission. The modulated signal is then transmitted through the antenna. And lastly, we will do the demodulation. And then at the receiver, the original message is accepted back through a process called demodulation. What is the application of AM in our daily life? AM is not just story, it is widely used in real life. First, AM is a radio broadcasting. It delivers news, music and even emergency alert. AM radio signal can travel very far, which is why it's still used in rural and remote areas. Secondly, it's an aviation communication. Aircraft communication use AM in the VHF band. This is essential for clear and reliable communication between pilots and air traffic control. Thirdly, it's a specialized radio. AM is also used in the citizen band radios, two-way communication device, and even in computer modern technique. Like, what are the types of AM? There are several variations of AM depending on how much the signal is being transmitted. The first one is DSBFC, which is a double sideband full carrier. This is the basic form. It has two sideband and a single carrier. Secondly is a DSBSC, which is a double sideband suppressed carrier. The carrier is removed to save the power consumption. Thirdly is SSB, which is a single sideband. Only one sideband and a carrier are being transmitted. Fourthly is a SSBSC, which is a single sideband suppressed carrier. Only one sideband is transmitted with no carrier. Highly efficient this one. And lastly is the VSB, which is vertical sideband, a compromise where one sideband is fully presented and the other is partly transmitted. This is usually in the TV broadcasting. You guys must be asked, what is sideband? Sideband, when a carrier is modulated with a message signal, new frequencies are produced. These are known as a sideband. If the carrier frequency is the FC and the message is a FM. Upper sideband is at the USB, which will be equal to the FC plus AM, while the lower sideband is the LSB is at the FC minus FM. Both sideband carry the information of the system message. That's why in efficient AM system, we try to eliminate the redundancy by removing unwanted sideband or the carrier.
Okay, next we will go for the difference between signal carrier and message signal. Carrier signal is a high frequency sinusoidal signal that carries the message signal over long distance. It does not contain information by itself. The purpose is to make transmission more efficient. For the message signal is also called modulating signal. It is the original information signal that you want to send. It's usually low in frequency and can be voice, data, video or sensory link. Now we will look at how AM signals are generated. Generation simply means the method or circuit used to produce a modulated waveform before it is transmitted. There are several types of AM generation. including double sideband full carrier, double sideband suppressed carrier, and single sideband suppressed carrier. Each with different which is direct and indirect technique. For AM double sideband full carrier, there are two ways to generate the signal. The first way is direct generation, and the second way is indirect generation. For direct generation, it uses a straightforward modulating circuit that varies the carrier amplitude according to the message. For indirect generation, usually involve producing double sideband suppressed carrier first, and then adding the carrier back later. This method is commonly used in standard AM broadcasting. Next is AM double sideband suppressed carrier. It removes the carrier entirely, improving power efficiency. Indirect double sideband suppressed carrier. A balanced modulator is used to cancel the carrier and leave only the sidebands. The indirect method also produces double sideband suppressed carrier, but it may involve additional filtering or phase shifting before transmission. Last, for single sideband suppressed carrier, it's only one-sided band. They have two, either upper or lower sideband is transmitted. A band pass filter is used to select which sideband passes through. It doesn't matter which sideband is chosen because both contain the same information.
So right now I'm going to explain about demodulation. So what is demodulation? Demodulation is the process of recovering or extracting the original message signal, which is information, from a modulated carrier signal that was transmitted through a communication system using a demodulator. When a signal is transmitted, it is first modulated, meaning the message is encoded onto a high frequency carrier. At the receiver, demodulation reverses that process and retrieves the original information so that it can be understood. For example, audio, data, video, and etc. Okay, so in this slide, I'm going to explain the four types of demodulator. The first one is envelope detector, also known as rectifier detector or error detector. This is actually the simplest form of demodulation because it's mainly use a diode and RC filter to detect the envelope of incoming AC wave. So the idea of the envelope of the modulated signal actually represent the original message signal. However, envelope detection only works properly when the carrier is strong and the modulation index is less than 1. Otherwise, the output may become distorted. But this is mainly used and commonly used due to its simplicity and low cost, making it widely used in AM radio receiver. So for the next step is called square law detector. This method is use a nonlinear device that produces an output proportional to the square of the input signal. As you can see there, square law detection, y equal to x square. When we square the AM signal, the part of the resulting terms will contain the message information. Then, by applying a LPF, which is low pass filter, we remove the unwanted high frequency component and extract the baseband message. So this method is more theoretically and often used when envelope detector is not suitable. So the third one is the SBSC synchronous detector, or known as double sideband suppressed carrier. In this case, we multiply the received signal with a locally generated, as we can see there, local oscillator, which is cos omega CT. That needs to be synchronized in frequency and phase with the original transmitting carrier. After the multiplication, a low pass filter with a low pass filter is used to remove the double frequency terms, leaving us the original signals. This technique is very accurate and demodulations, but requires precise synchronization, which makes the circuit slightly more complex compared to the other two before. And lastly is
SSBSC, synchronous detector, which means single sideband suppressed carrier. Again, this method multiplies the incoming signal with the local oscillator before filtering. So the main advantage of SSB system compared to the previous double sidebands is that it saves bandwidth and power because it's only use one sideband that is transmitted, and this type of demodulator is commonly used in long range distance or long distance communication, such as high frequency radio and aviation communication, where the bandwidth efficiency is important. So overall, each demodulator has its own purposes. Envelope detector are simple and low cost, while synchronous detection gives better performance and can be used for more advanced modulation scheme like the SBSC and SSBSC. So the choice depends on the system, whether the requirement is accuracy, complexity, and the type of AM that is used.
Next, we are going to highlight a recent breakthrough in field of amplitude modulation. Researchers has developed an ultra-thin time-modulated metasurface using graphene, allowing AM operation at frequency above 100 GHz. This advancement is very important for future 6G wireless system where extremely high data rates, efficient signal control are required. The benefit of this new technology are quite significant. It helps to enable precise beam shaping, energy efficient wireless communication system, and support high data rate transmission. In terms of impact, graphene-based metasurface have the potential to revolutionize wireless sensing, imaging, and communication devices, opening new possibilities for smart and connected environment. This shows how AM continues to evolve with modern material and engineering innovation. Before concluding, let's address one common misconception regarding AM technology. Many people assume that AM radio wave may be harmful. However, AM are non-ionizing radiation, meaning they do not carry enough energy to damage human cells or DNA. As shown on the slide, there are no credible scientific evidence linking to typical AM radio exposure to any health risks. AM transmitters are also operate under strict international and national security regulation, ensuring the public remains safe. This emphasizes the AM technology is not only effective, but safe for everyday use. Now, let's look at the advantages and disadvantages of amplitude modulation. On the advantages side, AM is simple and low cost to implement. It supports long-distance transmission, making it suitable for rural and emergency communication. AM system can work with existing infrastructure. They only require simple design antennas. However, AM also has certain disadvantages. It suffers from poor noise immunity, meaning static and interference can easily affect the signal. AM use power inefficiently because the carrier signal consumes energy but does not carry any information. It wastes bandwidth compared to more modern modulation technique. And lastly, AM signals are susceptible to fading, especially due to atmospheric changes. By understanding both sides help us to evaluate where AM is suitable and where other modulation schemes may perform better. In conclusion, modulation and demodulation are essential processes in communication system, allowing information to be efficiently transmitted and accurately recovered. Amplitude modulation demonstrates how a message signal can be carried over long distance by varying the amplitude of high-frequency carrier. Through the demodulation process, the original information is successfully retrieved, proving the importance of proper signal generation and detection. Overall, the study of AM provides a clear understanding of how communication system works and highlight both the strength and limitation of this method. So that's all from us. Thank you.